Good evening everyone. Sorry for my late lecture. Today I'm little late to the class. Good evening everyone. I hope that my audio and video is clear. If there is any problem, if you face any problem, you just write in the comment, please. And I had thought a little about Zeeman effect. Spectral lines under LS coupling and the Zeeman effect. I had also taught you the Zeeman effect. Just give me a minute. Just give me a minute. Good evening everyone. Thank you for joining my live. Give me a minute, please. Yes, coming to the normal Zeeman effect, this takes place. Normal Zeeman effect occurs for singlets, for which S is equal to 0. The multiplicity must be equal to 1, right? Yes. I'm late for today's class. Sorry for that. Sorry for the inconvenience. So we are discussing about Zeeman effect. About Zeeman effect. So this Zeeman effect is nothing but whenever an atom is placed, the atom which gives the spectral lines. Whenever the atom is placed, okay, the atom which gives the spectral lines is placed in the uniform magnetic field. The magnetic field will be uniform. So the spectral line will be splitted into several polarized components. If this is a single spectrum, according to Bohr, if this is a single spectral line, okay, whenever you place this atom in the magnetic field, this single spectral line will be splitted into several components, right? Several polarized components, and the Zeeman effect are of two types: normal Zeeman effect and anomalous Zeeman effect. Anomalous Zeeman effect. So this normal Zeeman effect takes place or occur for singlet, that is multiplicity will be equal to 1, singlet levels, and anomalous Zeeman effect takes place for multiplets. That means the splitting will be greater than 1, multiplets. To be 2s plus 1 to be 1, we have to consider this s must be equal to 0. S will be 0 for the electrons, which are antiparallel to each other. So S will be 0 when the electrons are antiparallel to each other. That means the subshells are completely filled. The subshells must be completely filled. Each subshell can be filled with 2 electrons. Okay, if the subshells are antiparallel to each other, then we will have this S equals to 0. Then we have the value S equals to 0. That means the atoms must possess the complete subshells. The completely filled subshells. Okay, this anomalous Zeeman splitting or anomalous Zeeman effect occurs for multiplets. That means S value must be greater than 0, right? For this purpose, the atom must possess valence electrons. Valence electrons. Okay, coming to normal Zeeman effect. Normal Zeeman effect. So, for S equals to 0 and the multiplicity 2s plus 1 is equals to 1. Okay, whenever you observe through the spectrometer, using a spectrometer, highly resolved spectrometer, what happens? You will observe a line which is parallel to the field. That means if this is a magnetic field and perpendicular to this magnetic field, you will be having electric field E bar. If this is the magnetic field B bar, perpendicular to this magnetic field, you will be having the electric field E bar. So whenever you observe through the spectrometer, you will observe that there will be a line which will be parallel to this electric field, okay, which is unshifted one, unshifted spectral line. This is an unshifted spectral line. This is known as pi component. This is named as pi component, and you will observe two more lines which are equally spaced from this pi component and named as sigma components. These lines will be perpendicular to this electric field, okay, and these are equally spaced. Okay, there will be a shift for this sigma lines. Okay, this one is unshifted line and these are shifted lines, and these are equally spaced from pi component. That means a single spectral line is split into 3 component or 3 polarized lines. Okay, so coming to normal Zeeman effect. The conditions are this: multiplicity must be equal to 1. That means S value is equal to 0. And here we are not considering the electron spin. Okay, write a note. Okay, very important points coming to this normal Zeeman effect. Okay, so what happens when you place the atom in the external magnetic field? When you place this atom in the external magnetic field, what happens? The L bar, that is orbital angular momentum, will precess about this magnetic field. Right? This will be the precision of L bar. This is the precision of L bar, and opposite to this L bar, this is L bar, and opposite to this L bar you will be having mu L bar. Okay, and this is the component. Lz will be the component, nothing but the projection of this L bar over B bar. If you observe carefully, if this is L bar and this is B bar, the projection of L bar will be Lz bar. The projection of L bar about this B bar will be Lz bar. And how many splits takes place? Let's see. The number of splits whenever an atom is placed in external magnetic field is 2L plus 1. This is one more important point. Just keep it in a box. And for example, for example, I'm taking D2 orbital whose J value is 2 and L value is equal to 2. Okay, for L value equals to 2, the number of splits will be equal to 2L plus 1. If you substitute L value in this 2L plus 1, you will be having 2 to the 4 plus 1 equals to 5. So D orbital or D level is splitted into 5 levels. Single D level is splitted into 5 levels. One is 0. Okay, and these levels are nothing but ML levels, which can take values from minus L to plus L, right? So you will be having ML for L equals to 2 will be minus 2, minus 1, 0, plus 1, plus 2. Okay, so the number of splits will be 5 splits for D orbital. 0, plus 2, plus 1, 0, minus 1, minus 2. You have to write the higher values above 0 and lower values below 0. Okay, this is a way to find out the number of splits. And coming to the magnitude of mu L bar or ML bar, you can also write ML bar. For convenient purpose, I am writing ML bar. ML bar equals to ML bar by L bar. In our last class, we have solved this equation, right? Did you remember? The magnitude of ML bar by L bar will be E by 2M. Did you remember this? And the component of L bar is LZ, which is equal to ML H cross, where H cross value is H by 2 pi. We had solved all these equations in our last class only. Did you remember? Did you remember this? So the precision here, L bar is precizing about the external magnetic field, and this precision is nothing but known as Larmor precision. Here L bar is precizing about B bar, and this precision is known as Larmor's precision. Larmor precision. And according to Larmor, the angular velocity, if this is external magnetic field B bar, the angular velocity of L bar is omega. This is given as mod of ML bar by mod of L bar. Okay, the angular velocity of L bar about this magnetic field B bar is mod of ML bar by mod L bar, and this is precizing about B bar, so I am taking the multiple of magnetic field B. Okay, angular velocity, and it can be written as EB by 2M. Okay, from this equation, this value is E by 2M, and it is a multiple of B, and this is nothing but angular velocity of L bar about B bar. And from change in energy equation, what is change in energy equation? Angular velocity into LZ bar. Okay, velocity into component of the orbital angular momentum component is LZ. LZ is nothing but the projection of L bar over B bar. Okay, and omega is the angular velocity. So from this equation, I am considering this as equation 1, this as equation 2. From 1 and 2 equations, the change in energy will be EB by 2M into MLH by 2 pi. Therefore, the change in energy delta E is equal to Rajesh. Good evening. Thank you for coming to my live. Delta E is equal to EB, and this is the mass of the electron. Okay, this is the mass of the electron. This is the mu L. Okay, mu L. For convenience, I am writing here ML. Okay, you can also take mu L, no need to worry. Okay, EB by 2 to the 4 pi m into mu L, okay, into mu L. This is a change in energy. Keep it in a box. This is equation number 3. This is equation number 3. And coming to our next equation, that is term value. Term value is nothing but delta T will be equal to delta E by HC. We had already find out these equations in our last class. Okay, if you just divide the energy equation with the HC, then you will be having this term value as EB by 4 pi MC into mu L. Okay, divide this equation, energy equation. I am writing here, multiplying and dividing with the HC. Sorry, dividing this equation with HC. Then you will be having delta T. Okay, so here, see, I forgot to write here H value. HH get cancelled. Therefore, you will left with EB by 4 pi MC into mu L. This is the term value. This is the term value. Okay, so as we know that this B is constant. Why? Because it is uniform, and E is constant, that is charge of electron. M is the mass of the electrons, is the speed of the light. 4 pi are constants. All these are constants. I am replacing this with L prime. Okay, therefore delta T is equal to mu L prime. Okay, where this L prime is Lorentz unit. Okay, all these are important formulas. You have to remember these formulas. We will use these formulas while solving problems. In our next class, we will solve problems. Okay, and is my voice clear? Is my audio and video clear? Please write in the comment. Okay, and coming to the selection rules for selection rules for normal Zeeman effect. Here we are discussing about normal Zeeman effect initially. Okay, and selection rules are for delta ml equals to 0, plus or minus 1. 0, plus or minus 1. Here the interaction is in between L bar, that is orbital angular momentum, and the magnetic field. Therefore, because of the magnetic field, which is a weaker one, the external magnetic field is weaker than the internal magnetic field. You have to remember this. Why? Because here we are neglecting the electron spin. We are not speaking about the electron spin. Okay, we are not speaking about the electron spin. We are just considering the external magnetic field is weaker than the internal magnetic field, and these will be the selection rules. Using these selection rules, we are going to find out the number of transitions between one level to the another level. And for example, I am considering diffuse level, diffused spectrum, that is D to P transition. Okay, so as we know that the number of splittings will be 12 plus 1. Therefore, for D level, the number of splittings will be 5. For P level, the number of splittings will be 3. So I am considering the D level. Okay, and drawing the number of splittings, 5 splittings. Okay, D level is split into 5, and P level is split into 3 levels. And this is D, this is P. For D, L value equals to 2. Okay, and you just write the ML values here, So this will be minus 2 by, because L equals to 2, minus 2, minus 1, 0, plus 1, plus 2. And for P, L equals to 2, right? Sorry, for P, L is equal to 1. So I'm writing plus 1, 0, minus 1 here. Now, according to the selection rules, delta ML will be equal to 0, plus or minus 1. Okay, the transitions from one level to another level must obey these selection rules, right? This is for normal Zeeman effect. So for easy purpose, I am giving you a hint here. You just draw initially the transitions for same level. First draw the transition between same energy levels. The transition between same energy levels, and then draw from higher to lower energy levels, and then draw lower to higher energy levels, okay. If you draw a line between same values, same energy levels, that means from 0 to 0, plus 1 to plus 1, minus 1 to minus 1. Okay, so here for these levels, delta ml value will be equal to 0. Why? Because 1 minus 1, see, you just find out the delta ml value. Delta ml value is initial minus final, initial level minus final level, that is initial ml value minus final ml value. See, initial ml value is 0, final ml value is 0, that means 0 minus 0 will be 0. Initial ml value is plus 1 and final ml value is minus 1, plus 1. So 1 minus 1 will be 0. Therefore, and minus 1 minus of minus 1 will be plus 1, this will be equal to 0. Therefore, delta ml value for these labels will be equal to 0. So in this way you can find out the delta ml values easily, okay. And also you can draw the transition lines between different levels easily, okay. Now draw higher to lower values, that means here we have plus 1, higher than plus 1 is plus 2, okay. These will be having same values, same delta ml values, and 0 greater than 0 will be plus 1, okay. Greater than minus 1 is 0, okay, 0. These levels will be having same delta ml values, that means see, my plus 2 minus 1 will be plus 1, okay. And plus 1 minus 0 is plus 1, 0 minus into minus plus 1 will be plus 1. So these transitions will be having delta ml values same, which will be equal to plus 1. And draw lower energy levels to higher energy levels, okay. So minus 2, lower than minus 2 will be minus 1, yes, minus 1 is greater than minus 2, don't draw, okay. Lower to higher, so from 0 to plus 1, draw 0 to plus 1, okay. And minus 1 to 0, and minus 2 to minus 1. So from lower to higher levels you will be having 3 more lines, and delta ml values will be minus 1. So if you draw the transition line from lower to higher level, the delta ml value will be minus 1. From higher to lower values, delta ml value will be plus 1. Same levels, delta ml value will be equal to 0. This is a trick to draw the transition lines. And for delta ml equals to 0, these transitions are pi components. You can name these spectral lines with pi, and these are sigma components. These transitions are sigma components, sigma transitions. So for D to P transition, you will be having total 9 transitions, 9 spectral lines. Out of these 9 spectral lines, each 3 spectral lines will be having same delta ml values. Okay, that means you will find three different spectral lines, or 3 different components, 3 different spectral components, which will be having same wavelength and same frequency. these three spectral lines will be having same wavelength and same frequency. Okay, so this is about a normal Zeeman effect. This is about normal Zeeman effect. And how to find out the wave number. If you are able to find out the wave number, you can also find out the wavelength. Here I am going to find out a wave number. Wave number nu bar is equal to, here we will be having change in wave number, so this will be equal to L prime, this will be equal to L prime, right, which is known as Lorentz unit. What's the value of Lorentz unit? EB by 4 pi MC. EB by 4 pi MC. And this delta nu bar is nothing but the separation between the consecutive Zeeman levels. If you substitute, you just substitute these constants. You just substitute these constants and find out the value and let me know the value. Write in the comment section. Write the values of charge of electron and this magnetic field in Tesla, and M is the mass of the electron and C is the speed of the light. So in your examination, the question will be like that. They will provide this value, magnetic field value, and you have to substitute the remaining constants, and you have to find out the distance between two consecutive Zeeman levels. You can find out the distance between two consecutive Zeeman levels. And coming to the anomalous Zeeman effect. Anomalous Zeeman effect. So anomalous Zeeman effect can be observed in the multiplicity whose multiplicity is greater than 1. That means you will observe this anomalous Zeeman effect in multiplets. That means you will find more than 3 lines, more than 3 spectral lines which will be having different wavelengths and different frequency. Okay, in Zeeman effect you will observe that all the 3 lines, that means all the 3 sigma lines will be having same wavelength and same frequency, pi and sigma. Okay, but in coming to anomalous Zeeman effect, you will observe one more line here. That means you will observe more than 2 sigma components and one pi component in anomalous Zeeman effect. Okay, or else you can write here more than 3 components. Okay, and here we will consider the electron spin. Okay, and whenever you place the atom in the external magnetic field, okay, and you will have a total orbital angular momentum J component. You will have a total orbital angular momentum J component Jz along this magnetic field. Okay, along this magnetic field. That means this J bar will precise about this external magnetic field. This is an external magnetic field. Okay, and this is the projection of Jz is a projection of J bar over this external magnetic field. Okay, and opposite to J bar you will be having mu J. Just because of here we are considering the electron, where electron is a negatively charged one. Okay, and coming to the selection rules of anomalous Zeeman effect. Definitely from spectral line, splitting of spectral lines topics, that is Zeeman effect, Stark effect, Paschen Back effect, and the fine structure spectrum, hyperfine structure spectrum, and hydrogen spectrum. From these topics you will be having at least two questions for your examination, any exam. Okay, and coming to the selection rules, delta mj is equal to 0 comma plus or minus 1. Here j is precessing about this b bar, that is external magnetic field. J is precessing about the external magnetic field. Therefore we are considering the selection rules for delta mj, who will be equal to 0 comma plus or minus 1. And not only that, here for mj equals to 0 to mj equals to 0, transition is forbidden. Here the transition from mj equals 0 to mj equals 0 is forbidden. Remember this point, very important point. Good evening everyone. And whenever delta j equals to 0, you will be having mj equals to 0. Okay, and coming to Paschen Back effect. Before that, I will give one example for Anomalous Zeeman effect. Just a minute, I will give you an example for Anomalous Zeeman effect. Example is P 1 by 2 transition to S 1 by 2 transition. Okay, you just find out the number of transitions from P to S. Okay, if I'm considering this P level, P 1 by 2, P minus 1 by 2, and for S also we will be having S 1 by 2, S minus 1 by 2. See, in our previous topics we considered only one S level, but here we are considering two S levels, just because here we are considering the electron spin. The electron spin will be positive if the electron is in upward oriented, and it will be negative if it is oriented in downward direction. Okay, that is plus 1 by 2 and minus 1 by 2. And you just find out the transitions, number of transitions for this delta mj equals to 0 comma plus or minus 1 value. Selection rules. Okay, you just find out this transition and give me the answer. Okay, I'm coming to our next topic, that is Paschen Back effect. Paschen Back effect. Paschen Back effect. Paschen Back effect. Good evening. Thank you for coming to my live. Thank you so much. Thank you for joining my live. And coming to the Paschen Back effect. So as I told just now, in our Zeeman effect, whenever we apply the external magnetic field which is weaker than the internal magnetic field, what happens? L is spinning or precessing about this magnetic field. L bar is precessing about this magnetic field. Okay, in Anomalous Zeeman effect, J bar is precessing about this external magnetic field. Here we consider J because of here we included the electron spin. Okay, electron spin. And coming to the Paschen Back effect, if you keep on increasing this external magnetic field, what happens? Here J is equal to L plus S, we know that. Okay, if you increase this external magnetic field, what happens? This L, the interaction between L and S break out. The interaction between L and S will be break out. Okay, break out, and separately. This L will spin separately about this external magnetic field, and S also will spin separately about this external magnetic field. Okay, whenever the external magnetic field is increased, the interaction between L and S will be break out, and L bar presses separately about this external magnetic field, and S bar also presses separately with about this external magnetic field. Okay, and if you keep on increasing, what happens here? The separation between energy levels. For example, these are the energy levels. Okay, what happens in the external magnetic field? What happens as L and S presses separately? The separation between these levels increases. Okay, and we know that if these are L levels, and in between these you will be having ML levels. Okay, as the separation increases, okay, I will take only two energy levels as the separation between these L values increases, for example. Okay, and here we have one more. This is L1 and L2. Okay, as this, if these are ML levels for L1 and these are ML levels for L2, and if the separation is increased, that means the separation of L1, I am taking L1 just for example. Okay, and what happens, the separation between these two levels increases. Okay, this is 1, this is 2, and this is 3. Level 1, level 2, level 3. Okay, so as the separation increases, what happens, this line will merge with this ML levels. Therefore, what happens here, this anomalous Zeeman effect will change to normal Zeeman effect. Anomalous Zeeman effect will change to normal Zeeman effect. Why? Because here, just a minute, Paschen Back effect. So here what is happening, both L and S are precessing separately. If you further increase this external field, this S bar will further presses faster, and L bar also presses faster, little faster. Okay, and opposite to this we will be having mu L and mu S. As it presses faster, what happens, there will be a precision, and they will merge with each other. If you observe, for example, if you are observing a star through a telescope, as the star is not at one position, not at rest position, it is moving. Okay, if you observe it through the telescope, initially the star will be at this position, after that it will be at this position. So the position of the star changes, and if you take a photograph of the star, so you will observe this pattern, right? This pattern, merging of the positions of the star, different position of the star. So in the same way you will observe this merging of ML and MS values, L and S values. Okay, so this what happens, same thing happens here, and because of merging of these different spectral lines, this anomalous Zeeman effect will change to normal Zeeman effect. This phenomenon is nothing but Paschen Back effect. Okay, and coming to one next topic. So this Paschen Back effect will be observed whenever this magnetic field is increased. Okay, I'm just checking if I missed with any point. So the selection rules for Paschen Back effect, let's see. Coming to our next topic, selection rules for Paschen Back effect. Selection rules. Selection rules for Paschen Back effect. Okay, here we are having ML and MS values. Why? Because L is precessing separately and S also precessing separately. Therefore, the selection rules will be equal to 0, plus or minus 1 and 0 for MS. Delta ML, delta MS. And coming to the energy, change in energy, initially you have to write the angular velocity for orbital angular momentum, which will be E by 2m into b, and for spin angular velocity it will be 2 times E by 2m into b. Why? Because as we know that WL is equal to GL by 2mb. This is the actual equation, and GL value is equal to 1, and omega s, not W, omega s equals to GS into E by 2m into b. We had discussed all these equations in our last classes only, and this GS value is equal to 2. I just substituted here 2. Okay, and write it directly. And coming to the change in energy for angular momentum will be omega L into Lz, which is equal to E by 2m times b into ml h cross. Lz will be equal to ml h cross. H cross is h by 2 pi. You just now multiply this. We will be having E into ml h b by 4 to the 4 m pi, 4 pi m or 4 m pi. This is for orbital angular momentum. And coming to the spin angular momentum, just write in running notes, keep a running notes. And coming to this spin angular momentum energy, okay, delta Es equal to omega s Ls. You just solve this equations by substituting omega s and the magnitude of Ls equals to ms h cross. You just substitute these values in this equation and you just find out the equation. Okay, it will be equal to 2e by 2m into b ms h cross, right? And if you solve this equation, it will be E by m into b into ms h cross. Now the total energy equals to sum of energy due to angular momentum and spin angular momentum, orbital angular momentum and spin angular momentum. This will be equal to ml plus 2ms into E h by 4 pi m into b. Very important equation. As we know that this value is equal to L prime. This will be ml2s into L prime. Okay, in this equation you have to substitute different ml values and ms values to find out the total energy. Don't worry, we will solve problems on these topics in our next classes. And from our next class I am going to give you problems. I'm going to give you problems with solutions from these topics. Okay, I will explain extra topic after completing atomic and molecular spectroscopy. Atomic and molecular spectroscopy topic complete చేసిన తర్వాతకి మనం ఏం చేద్దామంటే ఎక్స్ట్రా టాపిక్ డిస్కస్ చేస్తాం. గుడ్ మార్నింగ్ అర్నవ్, thank you so much for joining my live. Very nice, keep going. Thank you Arnav, thank you so much. Okay, and coming to the shift in energy is nothing but delta T, that is term shift, which is equal to delta E by hc. You just find the value This is your work. Okay. So the number of splittings will be 2L plus 1 into 2S plus 1. Number of splittings. Number of splittings. Splitting of each level. Each level is splitted into 2L plus 1 into 2S plus 1 times. Keep it in your box. Very important point. Okay, and for this I will give you one example, and I will close my lecture here itself. And we have to discuss Stark effect, right? In this lecture only I have to discuss Stark effect. Don't worry, I will discuss. And not only that, hyperfine structures. We have to discuss hyperfine structure also. Okay. So for p orbit, let us find the number of splittings. 2L plus 1 into 2S plus 1. Okay. So for p orbit, L value is equal to 1, S value is equal to 1 by 2. So therefore the number of splittings will be 2 into 1 plus 1 is 3 into 2 into 1 by 2 plus 1 will be 2. So therefore 3 into 2 will be 6. So p orbital is splitted into 6 levels. P orbital is splitted into 6 levels. Okay. 3, 4, 5, 6. P orbital is splitted into 6 levels. Okay, now write the selection rules for ML and MS. ML value, MS values రాయండి p orbital కి. రాసిన తర్వాతకి ఏం చేయాలంటే మీరు ఈ వాల్యూ ఫైండ్ అవుట్ చేయాలి. ఎనర్జీ ఈక్వేషన్ లో మనకి ఏమొచ్చింది, ఎనర్జీ ఈక్వేషన్ లో ML plus 2MS వాల్యూ ఫైండ్ అవుట్ చేయాలి. ML plus 2MS వాల్యూ ఫైండ్ అవుట్ చేయాలి. ఎలా నేను మీకు ఎక్స్ప్లెయిన్ చేస్తాను, డోంట్ వరీ. సో ఇక్కడ మనకి పైన వచ్చేసి 3 లైన్స్ ఉన్నాయి, కింద వచ్చేసి 2 లైన్స్ ఉన్నాయి కదా. సో డోంట్ వరీ, ఇక్కడ ఏమవుతున్నాయి అంటే Paschen Back effect లో 2 lines merge అయిపోతాయి. They will merge with each other. So let's see what happened. మనకి finally ML plus 2MS రావాలి. So for S value 1 by 2, L value will be minus 1. Okay, and S value 1 by 2, L value will be plus 1. And first of all we have to consider the higher levels, right? That means plus 1, 0, minus 1. This will be 1 by 2, 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 1 by 2. And next one plus 1, 0, minus 1. And S values will be minus 1 by 2, minus 1 by 2, minus 1 by 2. Now find out this ML and 2MS values. So ML is 1 and 2MS will be 1. Therefore 1 plus 1 is 2. For this value this will be 2. And here you will be having 2 to cancel, 1. This will be minus 1 plus 1. This will be 0. And this will be plus 1 minus 1. This will be also 0. And this value is 0, minus 1 is minus 1, and here you will be having minus 1, minus 1 is minus 2. Minus 2. Okay, so here if you observe carefully, these levels, both these levels will merge with each other. So ML plus 2MS for ML plus 2MS you will be having 0, 0 levels. Okay, 2 consecutive 0, 0 levels. Here we are having 2 consecutive 0, 0 levels. Is there any problem with the lecture? Is there any problem? Signal problem ఏమైనా ఉందో ఒకసారి చెక్ చేయండి ప్లీజ్. Okay, what happened? two consecutive levels are having same values, that is 0 and 0. That means as the external magnetic field is increased, what happens? These two levels will merge with each other. These two levels will merge with each other and form a single line. Okay, that means because of the external magnetic field, because as the external magnetic field is increased, these both lines are merged with each other, and you will be having 5 lines. You will be having 5 lines here. Okay, so in this way, as the external magnetic field is further increased, what happens? Remaining levels also merge with each other. Remaining levels will also merge with each other, and finally this anomalous Zeeman effect will change into normal Zeeman effect. Okay, this is known as Paschen Back effect. And coming to the Stark effect, and what we left with? Hyperfine structure, right? Hyperfine spectroscopy. Let's see. Coming to Stark effect, is the lecture is too lengthy. It's already 53 minutes, right? మన lecture length వచ్చేసి 53 minutes అయింది కాబట్టి I will close here and I will continue in a next lecture, that is I will teach Stark effect and hyperfine spectroscopy or hyperfine structure in our next class. See, మీరు కామెంట్ సెక్షన్లో ఎక్కువ కామెంట్ చేస్తుంటే, ఎక్కువ డౌట్స్ అడుగుతూ ఉంటే నాకు ఇంకా చెప్పాలి అనే ఇంట్రెస్ట్ వస్తుంది. ఓకే, ఇంకా చెప్పాలనే ఇంట్రెస్ట్ వస్తుంది. మీరు ఏంటంటే కామెంట్ చేయట్లేదు, అంటే మీకు అర్థమవుతుంది లేదు అనేది నాకు ఎలా అర్థమవుతుంది? కామెంట్స్ చేయడం వల్ల నాకు అర్థమవుతుంది. కామెంట్ సెక్షన్లో మీ డౌట్స్ క్లియర్ చేసుకోవడం వల్ల మాత్రమే నాకు అర్థమవుతుంది, మీకు అర్థమైంది టాపిక్ లేదు అనేది. కానీ ఇక్కడ ఏంటంటే క్లాస్ వింటున్నారు బట్ ఏం కామెంట్ చేయట్లేదు అంటే మీకు అర్థమవుతుందా లేదా అనేది నాకు అర్థం కావట్లేదు. సో ప్లీజ్ comment in the comment section whether you are able to understand or not. Okay, and if you didn't subscribe to my channel till now, please subscribe to my channel and click on the like button. If you have any doubt, you just write in the comment section. I will definitely clear your doubt in the same section or else in our next section. Okay, and I will teach these topics in our next class. Maximum it takes 20 minutes. 20 minutes లో ఈ చాప్టర్ అయితే ఈ టాపిక్స్ అయితే క్లియర్ అయిపోతాయి. దెన్ ఆఫ్టర్ we will solve problems related to atomic spectroscopy. నేను ఏం చేస్తా, ప్రాబ్లమ్స్ సాల్వ్ చేస్తా. టుడే ఇస్ థర్స్డే and on Friday and Saturday we will solve problems from this atomic spectroscopy. 2 days కూడా నేను ప్రాబ్లమ్స్ సాల్వ్ చేద్దాం. మ్యాక్సిమం ఒక 50 ప్రాబ్లమ్స్ సాల్వ్ చేయడానికైతే ట్రై చేద్దాం. అంటే కొన్ని ప్రాబ్లమ్స్ మీరు ఇంట్లో ట్రై చేయండి, వర్కౌట్ చేయండి, మీకు ప్రాబ్లమ్స్ ఇస్తా. ఎన్ని ఎక్కువ ప్రాబ్లమ్స్ సాల్వ్ చేస్తే మీకు అంత పర్ఫెక్షన్ అనేది వస్తుంది, అంతేనా? సో ఆన్ మండే ఐఎమ్ గోయింగ్ టు స్టార్ట్ మాలిక్యులర్ స్పెక్ట్రోస్కోపీ. ఆ వీక్లో నెక్స్ట్ వీక్ మొత్తంలో నేను మాలిక్యులర్ స్పెక్ట్రోస్కోపీ టాపిక్ క్లోజ్ చేసేసి మళ్ళీ నెక్స్ట్ వీక్ క్లాసికల్ మెకానిక్స్ స్టార్ట్ చేస్తాను. ఓకే, అండ్ ఇఫ్ యూ హ్యావ్ ఎనీ డౌట్స్ ప్లీజ్ రైట్ ఇన్ ద కామెంట్ సెక్షన్ అండ్ డోంట్ ఫర్గెట్ టు click on like button. Okay, and thank you for coming to my live. Thank you so much. I'm ending my